q, fourth root of 2 over q. Take alpha is equal to fourth root of 2, which is there in R, superset, not there in q. So we need to eliminate this. X power 4 is 2. X power 4 minus 2, 0. The coefficients are there in q now. So what is alpha equal to this? What is the degree in 4? Basis is 1 alpha alpha square alpha cube up to n minus 1. N is 4. 4 minus 1 is 3. So you need to take up to cube. So 2 power 1 by 4, 2 power 1 by 4 square, 2 power 1 by 4 cube. So 2 power 1 by 4, 2 power 1 by 2, 2 power 3 by 2. This is the base. Now let us enter into the Jordan canonical forms. With this, we have completed the algebra part. So there are certain gaps actually. Why I am doing like this is because this Venkat Lakshmi and all, they don't understand why we are doing mixed like this. See, there are certain topics, small topics. We have done actually for JAM and CSR combined first topics. Then later the CSR portion extended part is there that we have not done there. So that part I am doing under abstract algebra 2 and quadratic forms we have done under matrices. Everything we completed in matrices of the quadratic forms. But I said canonical forms, one small topic is there that I am going to teach separately only for CSR students. So that topics, those gaps I am trying to fill up. So that is the reason I mixedly I am doing. So with this I have completed abstract algebra extension part. So with that totally abstract algebra got completed. Now under linear algebra part, quadratic forms we have completed, but canonical forms, one small topic is left that we have not done. That I am going to do now. Okay, so take this now. So if A is equal to Aij n by n, already we have done linear algebra, characteristic equation, eigenvalues, eigenvector, shortcuts, everything we have discussed. How many solutions a system will have? What is algebraic multiplicity? What is geometric multiplicity? Is it diagonalizable or not? We have done so much in that, but the small part is left. So let us see. We are getting definite questions in CSR. If A is equal to Aij n by n, then characteristic equation of A is denoted by determinant A minus lambda equal to 0. This we have studied earlier also. This is also known as the polynomial satisfied by A. This determinant A minus lambda I is called characteristic polynomial. Polynomial, when you equate it to 0, it is called characteristic equation. And the determinant A minus lambda I is also called as a polynomial which is satisfied by A, or it is also called a polynomial which is that is a characteristic polynomial. A polynomial satisfied by A. What is a polynomial satisfied by A? Generally we take characteristic polynomial. Now, monic polynomial. Any polynomial with leading coefficient as 1 is called monic. In the beginning we have discussed. For example, x square plus 1 is monic, but 2x square plus 1 is not monic. So in case of characteristic polynomial, you may have coefficients as some, for example, if I have a matrix 1 by 2, 1, 1, 1 by 3. Because elements are rational numbers, characteristic polynomial you may get a characteristic equation you may get in the form 2x cube plus x square minus 1, 0. This is a characteristic polynomial, but not monic polynomial. Why not monic? Because leading coefficient is not 2. So if the entries in the matrix are rational numbers, then in the characteristic equation or characteristic polynomial when you take it, the coefficient need not be 1. But if it is 1, such a polynomial is called monic polynomial. Then what is minimal polynomial? There are, see, this is satisfied by characteristic polynomial. But there are many polynomials which are of degree less than characteristic, but still satisfied by A. For example, A is equal to I. So A, that is A minus I is 0. That means A is satisfying which polynomial? X minus 1 equal to 0. This is the polynomial satisfied by this. This is the polynomial satisfied by this. Is it not? X minus 1 equal to 0 is the polynomial satisfied by A. Why? Because we are getting, if you replace x by A, then you are getting A minus I equal to 0. But when A equal to I, you know that A square is also I. A cube is also I. That means A is satisfying not only x minus 1 equal to 0, A is satisfying x square minus 1 equal to 0. A is also satisfying x cube minus 1 equal to 0. That means A may satisfy a polynomial of any degree. That means there may be more than one polynomial which is satisfied by A. But among them, which is least degree, that is what is called a minimal polynomial. What is minimal polynomial? Among all the polynomials satisfied by A, least degree is called a minimal polynomial. The word itself shows. Minimal means least degree. Least degree polynomial satisfied by A is called as minimal polynomial. You know that characteristic polynomial always satisfies them. But less than that, what is the degree of polynomial that is satisfied? Okay, that is what is called minimal polynomial. Okay, now let us see. What is how to find out minimal polynomial? This Fauzia asked one day, asked to discuss that also. So that is the reason why again I went to this minimal polynomial. Also I require for this Jordan canonical forms. So for Jordan canonical forms also I want this concept. So here, what is minimal polynomial? Least degree monic polynomial satisfied by A is called minimal polynomial. What is the general form of first degree polynomial? In general, degree of the minimal polynomial will be less than or equal to degree of characteristic polynomial. In general, degree of minimal is less than or equal to degree of characteristic polynomial. Generally, maybe equal or less. Now, what is the first degree monic polynomial or minimal polynomial? It will be in the form x plus r. Why? Because it should be monic. Monic means degree should be 1. What is r? Constant which you have to find. What is the form of second degree minimal polynomial? X square plus px plus q, because it has to be monic. So x square coefficient should be 1, x p q. Only leading coefficient should be 1. Remaining can be anything. So again we have to find p and q if it is minimal. How to find? I will show you. Degree of minimal polynomial is in general less than or equal to degree of characteristic polynomial. CP means characteristic polynomial. Minimal polynomial means MP. Degree of MP, if it is equal to degree of CP, it is equal, then A is said to be derogatory. When is matrix said to be derogatory? If the degree of the minimal polynomial is equal to degree of CP. If it is not equal, then that is lesser. Degree of MP less than CP, then it is said to be non-derogatory. So if you are asked to test whether it is derogatory or not, you have to get the minimal polynomial, find its degree, is equal to this, then it is derogatory, otherwise non-derogatory. In general, minimal polynomial is always a divisor of characteristic polynomial. In general, minimal polynomial divides characteristic polynomial. Find minimal polynomial, for example. Is it derogatory or non-derogatory? We know the degree of that is the degree of characteristic polynomial equal to order, which is equal to 2. How to get minimal polynomial? Always you have to start with the least degree. Least degree means first degree. Let x plus p be minimal polynomial. So by definition, it is satisfied by A. That means if you replace x by A plus p I will be 0. Because A plus p has no meaning. So whenever there is constant, if you replace x by A, we need to multiply by I. Because we can add only 2 matrices. We cannot add a constant to matrix. So A plus p is 0 for some p. you have to get P. So this is 1, 1, 1, 1, P 0, 0, P, which is equal to 0, 0. Let this one be minimal. Then add equator. We have to get P value. We have to get unique P. 1 plus P is 0. If and only if 1 is 0. So when are two matrices said to be equal? Provided each and every element is same. Whatever is the P value, even if you take P equal to minus 1, P equal to minus 1, if you substitute 1 minus 1, 0, 1 minus 1, 0, but you get 0, 1, 1, 0. You will not get 0 matrix. That means whatever is the P, 1 cannot be equal to 0. That means there exists no P. Why we are getting such absurdities? There exists no P satisfying this. Whatever is the P value, this can never be equal to this. Because
Ma'am,
1 cannot.
P value can you say once again, ma'am? Here, 1 plus P.
You tell me, 1 plus P 0 means what is P? 1 plus P 0 means what is P?
Minus 1, ma'am.
Minus 1 is substitute here. What will you get? 0, 1, 1, 0. Is it equal to 0, 0, 0, 0? No.
Okay.
So whatever is the P value, it can never be equal to 0. 0 matrix. Because 1 cannot be equal to 0. 1 equal to 0 is an absurdity. Why we are getting such wrong results? Because something wrong in our assumption. What is wrong in our assumption? We have assumed x plus p as minimal polynomial. Therefore, we are getting absurdity. Therefore, x plus p cannot be minimal polynomial. So, first degree polynomial cannot be minimal. So, it has to be next degree. What is next degree? 2. So, degree of minimal polynomial is always less than or equal to Cp. That means it should be less than or equal to 2. Less than or equal to 2 means it should be 1 or 2. It cannot be 1. Because if it is 1, we are getting wrong result. We are not able to find out a P satisfying this equal to this. We are able to get a P. But when you substitute back x plus pi, we are not getting equal to 0. This equation not satisfied. Therefore, there exists no first degree MP. So, only choice for us is, it is not lesser. Therefore, it has to be equal to only 2. Therefore, since degree of MP is not 1, we get degree of MP must be equal to degree of Cp, which is 2. So, if the degrees are equal, then we say it is derogatory. And what is minimal polynomial? It is same as characteristic polynomial. What is characteristic polynomial? Determinant a minus lambda I. But you know, eigenvalues of this are 0, 2. We have done this shortcut earlier. By looking at the matrix, how to get eigenvalues we have seen. Do you remember? In matrices we have done. For this, the eigenvalues are 0 and 2. We have done there. So what is the characteristic polynomial? X minus 0 into x minus 2, 0 is the characteristic equation. What is characteristic polynomial? Only left side. This is polynomial. If you equate it to 0, it is equation. This is characteristic equation. So x into x minus 2, that is x square minus 2x is the required characteristic polynomial. It is also the minimal polynomial. Therefore, minimal polynomial is equal to characteristic polynomial is equal to x square minus 2x. It is derogatory or non-derogatory? It is derogatory. So if they are not equal, non-derogatory. Suppose degree of MP is 1. That means suppose you are able to find out a P. After finding P, if you substitute back here, suppose LHS equal to RHS, then we say that x plus whatever is the P is the minimal polynomial. Its degree is 1, less than 2. Therefore, it is non-derogatory. But here we are not able to get a P satisfying this. Therefore, degree of MP must be equal to degree of C. Therefore, we say it is derogatory. Okay. This is the one. So, given a matrix, if you are asked to test, you can prove using that. But you are getting questions from the Jordan canonical. Its main important is this. Jordan canonical form. What is meant by Jordan block? Definite questions again. The matrix of the form diagonally lambda. Above all ones. Pre-diagonal 1. Diagonal lambda. What is lambda? Eigenvalue. If it is remaining all zeros, if it is in this form, such a block is called Jordan block of the matrix, corresponding to which eigenvalue? Lambda. Corresponding to eigenvalue lambda, the Jordan block is this. How to get Jordan block? Take the eigenvalue corresponding to every eigenvalue, you will get one block. So corresponding to this lambda, this is lambda, 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 above all ones, then this is what is called as the Jordan block corresponding to lambda. For example, the eigenvalue of the characteristic polynomial, for example, is x minus 2 whole square. Characteristic polynomial. Then what is the eigenvalue? 2 is the eigenvalue. What is the block corresponding to this? X minus 2 equal to 0 means x equal to 2 comma 2. That is the eigenvalue is repeating how many times? 2 times. So if it is repeating 2 times, you will get a 2 by 2 block. If it is repeating 3 times, you will get a 3 by 3 block. How many times it is repeating, you will get that order block. So order of the block depends on how many times the eigenvalue is repeating. How many times an eigenvalue is repeating is called algebraic multiplicity. So here that also we have done earlier. What is the Jordan block corresponding to this? It is repeating 2 times. 2 by 2 block. What is that block? You have to take eigenvalue lambda diagonally. Above we have to take 1. Remaining 0. Remaining only one place is there. This is called Jordan block corresponding to x minus 2 whole square. For example, if it is, x minus 3, x minus 2 whole power, for example, 3. What is the Jordan block? We'll get 3 by 3. Take 2 3 times. 2, 2, 2. Above all ones. This is the Jordan. Diagonally 1. Above the diagonal ones. Remaining all zeros. Pre-diagonal, that is immediately preceding diagonal entry should be ones. Diagonal should be lambda, pre-diagonal should be 1. Remaining all zeros. Then we call that as the Jordan block corresponding to that particular eigenvalue. Somebody may get a doubt. Suppose, madam, it is not repeating, then what is the Jordan block? For example, x minus 2 is there. Only one time. What is the Jordan block corresponding to this? Because the power is 1, you will get only 1 by 1 block. That is given by 2. Okay? Let us see how to get. This is called basic Jordan blocks. Let T from V to V be a linear operator whose characteristic and minimal polynomials are given by this. This is characteristic polynomial delta x. This is minimal polynomial. See, whatever factors that are there here will be present here, but the degrees will not be same. Minimal polynomial degree will be less than or equal to this. M1 less than or equal to N1, M2 less than or equal to N2, Mr less than or equal to N. Lambda I are distinct scalars. Then T has a Jordan block. Then what is the Jordan block corresponding to this? It's given by J1, J2 and so on. What is J1? It is the block corresponding to lambda 1. What is J2? It is the block corresponding to lambda 2. What is JR? It is the block corresponding to lambda. Then how to formulate? What we have to do is, pay attention. For each lambda I, the Jordan block is this. The corresponding blocks Ji have the following properties. How to constitute them? Is there is a rule. There is at least one Ji of order Mi. What is Mi? Which is there in minimal polynomial. There should be at least one block which is of order M1. Remaining all blocks should be of degree less than or equal to M1. So how we have to split this is N1, we have to split it as x minus lambda 1 whole power M1. We have to split. How to split is, I will show you. When we work out problems, it will be clear. There should be a Jordan block of degree at least M1 and remaining should be less than or equal to M1. Again, corresponding to lambda 2, there should be at least one block which is of order M2. Remaining all should be less than or equal to M2. This should be followed for all the eigenvalues. After getting them separately, arrange each block diagonally, remaining all zeros, then such a form is called Jordan canonical form. I'll show you in the problems. Determine all possible Jordan canonical forms of order 5 whose minimal polynomial is this. Please pay attention. Now, by chance, if the meeting stops in between, for today I want to take one more session and complete this. So you rejoin again. I will not take much time, but it may require. If it stops in between in the explanation, because I will be involved in the explanation, I will not see there. So if the meeting stops, again rejoin for today. Now, please concentrate. This girl, who is this girl? IIT JAM students, you need not rejoin. JAM students need not rejoin. This topic is only for the CSIR. If you want, you can leave now also. Now, because to your level it is difficult because they have done already in their MSc courses. So for you, you can leave. JAM students can leave. You don't have this topic. This and the next. You need not join. Join tomorrow by 6 o'clock. ODE will be started tomorrow. Now, m of x is x minus 2 whole square. Delta of x is x. What is the required? Determine all possible Jordan canonical forms for a matrix of order 5 whose minimal polynomial is this. So minimal polynomial is x minus 2 whole square given to you, but delta x not given. Need not be given. Why need not be given? Because it is of order 5. You know that characteristic polynomial degree will be equal to order of the matrix always. So x minus 2 whole power 5. There is only one factor. Therefore, here also we have to take only one factor. But degree should be equal to order of the matrix. This we call. Now, what is the maximum order of the block? Corresponding to this 2, what is the maximum order? It is 2 by 2, 3 by 3, 4 by 4. How much we have to have order? That will be decided based on the degree of the minimal polynomial. Because we stated n by n. So what is the order? That will be decided. The order of the block will be decided based on this minimal polynomial degree. What is the degree of the minimal polynomial? 2. So there should be a block of order 2. So you have to see least out of it. What is least 2? So there should be a maximum order of the block is corresponding to this is 2. Corresponding to eigenvalue 2, what can be the order of the maximum block is 2. But you are having 5 here. Then how to get remaining? Total 5 we should get. We are having only 2 by 2 block, but we should get 5 by 5 matrix. So remaining should be such that it should be less than or equal to 2. That means they should be 2 and 1. Or They should, because already one block of order 2 we got. But order is 5. We should get a 5 by 5 matrix. But here we get only 2 by 2. But we should get 5 by 5. How to get 5 by 5? Remaining blocks should be of order 2 and 1, so that when you add 2 plus 2 plus 1 is 5. Or they can be either equal to this or less than this. So we can have 1, 1, 1. Here 2 is there, here 1 plus 1 plus 1, 3. So delta x, how to split characteristic polynomial? We have to split characteristic polynomial based on minimal polynomial. So what should be the blocks? One block should be of order 2, maximum order should be 2, remaining can be either equal to 2 or less than 2. So what should be the remaining blocks? Maximum 2 or 1. I cannot have one more 2 here, because 2 plus 2 plus 2 becomes 6. We should have only 5. So how to split this is based on minimal polynomial. So split this as x minus 2 whole square, x minus 2 whole square, x minus 2 whole power 1. So the 2 plus 2 plus 1 becomes 5. This splitting should be done depending on the degree of the minimal polynomial. So maximum, you cannot split x minus 2 whole cube into x minus 2 whole square, not allowed. Why x minus 2 whole cube not allowed? Because maximum power is 2. Maximum power of the block should be out of the minimum, this whichever is there, that only you should have. You cannot split like x minus 2 whole cube into whole square, not allowed. Maximum out of the block is equal to degree of the minimal power. So you have to split based on that. You can have either 2 or less than 2, but not greater than 2. So what should be the order of the blocks? 2, 2, 1. So the 2 plus 2 plus 1 becomes 5. Here also, x minus 2 whole square, you can have less than 2. Less than 2 means 1. So first order, first order, first order. What are the orders? 1, 1, 1. So 1 plus 1 plus 1, 3, 3 plus 2, 5. Like partition. Yesterday we have discussed what is going to be partitions. N1 should be greater than or equal to N2. Exactly same that. Here they are equal to the partition. Once you do this, what is the Jordan block? How do we write that? Look at this, please. Corresponding to this now, I am going to write the Jordan block. What is the Jordan block corresponding to this? Because power is 2, we should have 2 by 2 block. What is 2 by 2 block? 2, 1, 2 by 2 block. This is a 2 by 2 matrix. Diagonally 2, above 1, below 0. This is a 2 by 2 block. Next, one more 2 by 2 block. You have to arrange blocks diagonally. You have to arrange blocks diagonally. What is one more block here? 2 by 2 block? 2, 1, 0, 2. Because this is the one corresponding to this. This is 1 by 1 block. What is 1 by 1 block means? Only 1. Above you should not write 0. You should not write 1. If you write 1, it means this total is 1 block. 2102 means if you write 1 above, that means it is a 2 by 2 block. If you write a single above 0, that means this is x minus 2, single 1. So what you have to do, corresponding to this, you find the block separately, for this block separately, for this block separately, arrange them diagonally, remaining all zeros. So what we have to do here? What is the block corresponding to 2 by 2? Earlier we have seen what is the block means? Arrange eigenvalue above 1. This is called 2 by 2 block. Then one more 2 by 2 block. Arrange diagonally. What is the order? 5 by 5, because order is 5. We should have 5 by 5 matrix. Take a 5 by 5 matrix. How will you write? Take a 5 by 5 matrix and then arrange this 2, 1, 0, 2, 2 by 2 block. Again 2, 1, 0, 2, 2 by 2 block, and then single 2. It is 5 by 5. Already 2 elements are there. How many elements you will get remaining? 3 elements. Zeros. Here 2, 1, this is a diagonal. So this is 0. 0, 0, 0. Here we are arranging diagonally 4 series. Arrange a 5 by 5 matrix. Blocks you have to arrange diagonally. These are the blocks. Everywhere remaining 0. This is called as, each one is called Jordan block. If you arrange blocks diagonally, remaining zeros, then it is called Jordan canonical form. Corresponding to this. Jordan canonical form is not unique. You can get more than one canonical form. It is based on the way we split. The way we split gives rise to the block. So here we can have one more. You can see how we do. How did we split? Only 2 by 2 block 1. Remaining all single blocks, 1 by 1 blocks. So what is the block corresponding to this? 2 by 2 block means 2, 2, 1, 0. This is 2 by 2. Remaining all are single blocks. That is 2, 2, 2.
Madam,
Now, yeah.
మేడం ఈ బ్లాక్స్ జంబుల్ చేయొచ్చా అంటే ఇప్పుడు మీరు అంటే బ్లాక్
You can have 2, 2, 2 here. You can have first x minus 2. You can have this here also. Very good question. See, this is you can jumble also. First you can have this and then this. That is the reason why it is not unique. Many possible ways are. Okay. Now here also x minus 2, x minus 2, x minus 2. You can write this here also. This block you can write in the border, in the bottom. You can have 2, 2, 2 here also. You can. Okay. Did I answer your question?
Yes, ma'am. Yes, ma'am.
Yeah.
Thank you.
So now what we have to do? We have to arrange these blocks. How to arrange them? Arrange them diagonally. How to arrange them diagonally? First I am arranging this 5 by 5 matrix. First I am arranging 2 by 2. Then all single 2s. Because 1 by 1. 1 by 1 blocks. Remaining all elements, zeros. You can play with this if you understand. So arrange the blocks diagonally. Remaining all zeros. Complete 5 by 5 matrix. This is what is called Jordan block. What she asked is Jordan canonical form. You can also have like this also. What she asked is this. Can we write 1 by 1 blocks in the beginning? Towards end, can we write this? Yes, you can. Remaining all zeros. Zeros. Remaining all zeros. You can have. First 1 by 1 blocks, then 2 by 2. That also. That's what she asked. Can we have order of the blocks 2 by 2 in the bottom? You can. In between also you can have. But what is important is there any 2 by 2 block order? Remaining blocks are of order less than this order. That is it. So based on that you get many canonical. So given any problem, how will you identify in the exam if it comes? Because there are many ways I am only saying. Then how will you identify in the exam? Which of the following is canonical form? Suppose the question is given. How will you do that? Then what you have to do is, look at this. Please rejoin after 5. If the meeting ends, please rejoin for today. So what you have to do is, from the options you have to come. First you split and keep. Then from the options you come. How will you identify? There should be maximum order 2. So find out the orders of the blocks. What is the order of the block 2? What is the order of the block 2? Order of the block 1. So maximum order of the block should be 2. Remaining 1. Less than 2. Less than 2 means 1. Are they satisfied? Total order of the matrix, is it coincident with delta XR? When you add the powers, you should have 5. Because 5 is the order of the matrix. That's how you have to check. Here also, what is the maximum order of the block? It may be anywhere, here in the bottom, anywhere. You cannot write all. So after splitting, because yours is MCQ exam, come from the options. Find out the orders of the blocks. 1 is there means it is 2 by 2 block. 0 is there means these are all single blocks. So what is the order of this block? 1. What is the order of this block? 1. What is the order of this block? 1. What is the order of this block is 2 by 2. So there is maximum order block is 2, remaining 1, 1, 1. Therefore, total when you are adding it is 5. So this is the required Jordan. More than one correct option in the part C you will get. So this is also correct. This is also correct. Suppose these two are given here and this is given at the bottom. That is also correct. So come from the option. Split this, keep it aside, go to options. What is the maximum order of the block? You can have any number. For example, here I got 2 by 2 blocks 2. Single one order block only one. You can have any, but each order of the block should be less than or equal to minimal polynomial degree. Total blocks when you add, it should add up to the order of the blocks. That is it. Now, let us see next question. You will follow. If I do 2 or 3 problems, then it will be clear. Delta x is x plus 8 whole power 4 x minus 1 whole. What is mx more? X plus 8 whole cube x minus 1. What is the difference? Earlier I took only one eigenvalue. Now 2 eigenvalues. Now, each eigenvalue we have to see. Now x plus 8, here 3, here 4. That means corresponding to minus 8. What should be the maximum order of the block is 3 or less than or equal to 3. Now total should add up to 4. Total add up to 4. So there should be a block of order 3 compulsory and the remaining should be of order 1. Only 1 is possible actually, less than 3. Less than 3 means 2 or 1 you can have. But if you take 2, 3 plus 2 becomes 5. But you are having only 4. So you have to split this x plus 8 as x plus 8 whole cube. This 3 is there, here 4 is there. So what is 4 minus 3 is 1. Total should be 4. So already 3 we have used. So we should have only one more block 1. So that 3 plus 1 becomes 4. That's how you have to split. Next, x minus 1 whole square. 2 and 3 corresponding to 1. 2 and 3 minimum is 2. So what is the maximum order of the block is 2. So that means x minus 1 whole square into the remaining 1. Total should be 3, no? Already 2 we took. How much we have to take so that it adds up to 3 is x minus 1. So that 2 plus 1 is 3. Here 3 plus 1 is 4. So maximum order should be this.